Scientists have discovered a new way to predict Mount Etna's next eruption. Researchers analyzed changes in the ratio of small earthquakes to large ones beneath Mount Etna over time, and found a strong correlation with the volcano's activity over the past 20 years. This newfound way to monitor magma movement beneath Mount Etna could help scientists predict when it will erupt. Mount Etna, located on the Italian island of Sicily, is Europe's largest active volcano. Humans have documented its activity for the past 2,700 years, but the volcano's eruptive history stretches back 500,000 years. Mount Etna's last eruption, in June 2025, sent a giant ash cloud 6.5 kilometers high and triggered avalanches of hot lava blocks and other debris. These eruptions are often predicted, allowing officials to issue warnings on the morning of the event. But predictions are not always accurate. This new method could make it easier to predict Mount Etna's eruptions. In a new study, researchers at the Italian National Institute of Geophysics and Volcanology analyzed a parameter called the B value, which describes the ratio of low-magnitude earthquakes to high-magnitude earthquakes in a region of the Earth's crust. This ratio can change as magma rises through the crust toward the volcano's summit. The researchers report in a study published October 8th in the journal Science Advances. Changes in the B value over time reflect how the pressure inside the volcano evolves. The study's lead author, Marco Fajardo Carlino, a geophysicist at the INGV's Etna Observatory, told Live Science in an email. Because magma ascent triggers pressure changes within the crust, tracking the B value can help reveal the different stages of magma migration from depth to the surface. Mount Etna is located in the collision zone between the African and European tectonic plates. As a result, there is a vertical fault in the Earth's crust known as a strike-slip fault at the base of the volcano, making it easier for magma to rise to the surface, according to the study. The crust beneath Mount Etna is up to 30 kilometers thick. Magma rose through this volume before the eruption, but instead of refilling a single magma chamber, the molten rock filled a series of interconnected storage zones embedded in the crust at varying depths. The deepest magma storage zone is 11 kilometers below sea level, Ferreto Carlino explains, and this zone feeds an intermediate storage system with various zones likely extending 3 to 7 kilometers deep. As the magma rises, it moves through a complex network of fractures and eventually reaches the final storage zone, located above sea level within the volcanic edifice. The researchers had a wealth of data to process and extract B values from, given Etna's frequent activity. They analyzed seismic patterns in the crust along a 19-mile stretch beneath the volcano from 2005 to 2024. With particular attention to how these patterns varied across crustal regions.